Okay, so this numerical test portion 8E, it will include these portions here, the test questions. Okay, you can write it down. Let's start with the first question, that is 5. This is on textbook, page 117. Okay, in this class we will do this 5 and this question number 1. Okay, and in the next class, the next two, this is 2 and 4. Okay, so let's go and read the question. Let me read the question for us. A stone is thrown in a vertically upward direction with a velocity of 5 meters per second. That means there is a stone that has been thrown in this upward direction. Let us say up to, went to maximum height this much. Let us say S. Okay. Now it is thrown with a velocity, initial velocity of 5 meters per second. We know this will be initial velocity because it was thrown up with that. So that is the first velocity, so it's initial. So we can write here u is equal to 5 meters per second is the initial velocity, which is actually the velocity with which the stone was thrown upwards. Okay, now let us remember this. You can write it down as a side note on your notebook here. For object thrown upwards, okay, for an object that is thrown upward direction against gravity, okay, for them v is always going to be 0 meter per second. Okay, 0. Now you can understand that easily. Look here, if I throw this ball up, then initial velocity, there is with some initial velocity, then when it reaches the maximum height, for a momentarily it will hang in the air. When it reaches the highest point, it will hang in the air and stop, right? That's why the final velocity means the velocity at the highest height, that moment where it stopped. That's why it is 0 meter per second. Okay, and then keep this one in mind for the object. Now the reverse, that is, this is thrown, n. Okay, thrown, object dropped. For the object dropped from a height, like you drop this ball go to the top of the building and drop it. Then before you drop it, just before you drop it, it is stationary in your hand, right? So in such case, the initial velocity will be 0 meter per second. So we need to know this, that for an object that is thrown up, the final velocity where it hangs for a moment stationary, final velocity is 0. But for object that is dropped before being released, it is stationary. So initial velocity will be 0 when object is dropped, and final velocity will be 0 when object is thrown up. So we have to keep that in mind. Now in our question here, it's very clear that the object was thrown upward. So its final velocity here, v, will be therefore 0 meter per second, because you can say here, since it was thrown upwards, that's why we know the final velocity will be 0. Okay, so this is the final velocity. Okay, now let us continue to read the question. If the acceleration of the stone during its motion is 10 meters per second square in the downward direction, let's write that for understanding. Since here acceleration, well, let's just shorten it, is 10 meters per second square in the downward direction. Question clearly tells us that acceleration is in the downward direction. That means your a here will be minus 10 meter per second square, because the acceleration is in the direction, downward direction means direction opposite to the stone movement, the stone is thrown upwards, but the acceleration is going down, means when acceleration happens opposite to the direction of motion, that is the motion of the stone, it will be negative. Now we have learned this in our previous numericals also. So here, or we can simply understand it this way. When an object is thrown up, right? When an object is thrown up, it is going to slow down. You can understand it this way also. See here, thrown up. Then initial is very high velocity, 5, but as you go higher and higher, it becomes 4, 3, like that it will decrease. So if the velocity is decreasing with time, that is called negative acceleration. If the velocity is increasing with time, it's called positive acceleration, like a racing car increasing the speed, right? Or when a car is slowing down by application of brakes, that is negative acceleration. So here also the stone was very high speed, but as you go higher and higher, it will become slower and slower. We know this from our day-to-day life also. When you throw an object, it becomes slower, till it reaches the highest point, it stops actually. So its velocity is decreasing along with time, means it's negative, right? So we write here minus. Okay, so this is here minus because it's downward direction, opposite to the upward movement of the stone, opposite to the motion of the stone, which is upwards. Okay, so we have got that. Now let us go to the next one. What will be the height attained by the stone? So let us write here, that is S is question mark, is the height attained, okay, attained by the stone. This is actually the maximum height to which the stone will reach. That's what it means, which is S here. Okay, and then how much time will it take to reach there? So to reach this S height, how much time will it take? So these two things we have to find out. So this is the time taken. So let us start with the S. Now as we see here, S has two formula here, ut plus half a t square. But we cannot use that because time is not yet found. So we go to the next and check. A is there, just now we saw, minus 10 meter per second square. V is there, here, 0 meter per second. And U is there, here, 5 meter per second. So everything is there except the S. So we can easily use this formula. So for the first one, we can just write here, since twice AS we know is equal to V square minus V square minus U square. Okay, V square minus U square. We can arrange this one and write S is equal to V square minus U square divided by this portion. It will come down, right, 2A. So next here, that will be equal to here. V here is 0, so we can just write there 0 meter per second, whole thing square, minus U here is 5, you see here, so we can write that one down, 5 meter per second, and whole thing square, right? So here 2 into A here is minus 10 meter per second square, so we can write that minus 10 meter per second square and close the bracket. Now here we can write by simplification 0 to the power 2, 0, everything 0, and minus here 5 5s are 25. This square will go to meter also, meter square. 2 1s are 2, so 2, and plus and minus, minus, so minus 2 power. Then down here, plus and the minus, minus 2 10s are 20, and here meter, and here second to the power minus 2. So we can cancel this, and meter, and here 1 gone, so only 1 more left, right? So minus and minus can cancel. 5 4s are 20, so this will be here sorry, here 5 5s are 25, sorry. So here, slight correction, sorry, this one here, we forgot this one, 5 square means 25, right? And here minus 20, 2 10s are 20, sorry. Then 5 4s are 20, and then 5 5s are 25. So 5 divided by 4 is a simple case of 4 1s are 4, 1 in hand, point, 0. 2s are 8, 2 in hand, point, so I can put 0 here. 4 5s are 20. So the maximum height that the stone will reach is 1.25 meter. So we got that one. Now next here, we can find the t by, I think, using the first equation here. So we have v, we have u, we have a. So directly we can use that. So v is equal to u plus at. So that implies, keep this t that you're going to find out, don't move. This one also same place. Shift this one this side, then plus u will become minus u. And don't move this, but move this means into down, it will go here. So I'm just doing directly, okay, because you're used to it by now. So here, that will give you here v is, as you can see, 0 meter per second. So 0 minus u is 5, and common unit is, you can take out of the bracket, meter per second. See here, these two common unit, you can take it out of the bracket as a common factor. And a is minus 10 meter per second square, as you can see here. So next, it will give you here, okay, as you come and solve, you will get here 0 minus 5 is minus 5 meter per second divided by, this one is minus 10 meter per second square. So here, this meter can cancel. Second to the power minus 1. Here 2 minus 1, so still one more is there. Minus cancel. Then 5 divided by 10 means decimal move left to the left side of 5 here, so 0.5. And second to the power minus 1, you can shift to the numerator, then second to the power plus 1, which we normally don't write, isn't it? So time is 5 seconds, second answer. So you can just write here, therefore, height attained by the stone, which is denoted by S in our question, is 1.25 meter, and time taken to reach that height, which is denoted by t here, is 0.5 seconds. So these are the two answers, right? Let's go to the next one. Question number 1. In this class, we'll do these two questions. And this question number 1 is on textbook, page 119. So let us go there. Okay, let us go to page 119. I will read the question for us. Let us do slowly so we understand it well, okay? An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. So there is a circular track on which a person, an athlete, means a sports person, is running. The diameter of this circular track, okay, is 200 meter. The radius we don't know yet, r there, line joining center to the circumference, okay. So this is the situation. So let us write this one down. Let us just write here for the circular track, okay, for the circular track, we have here, let us say r is the radius. We know it's diameter divided by 2. So this will be 100 on 100 meter on cancellation. So this is your radius of the track. Okay. Now, the question is saying, let us go and see there. He completes one round of the circular track in 40 seconds. So you write here, distance covered in 40 seconds. According to the question is one round. One round means he start from here, then in the boundary he went and completed. That's called one round, and that is called circumference. Distance covered in going time, going once round the circle is called circumference. So that is formula 2 pi r, right? So that will be equal to 2 into 22 by 7 into 100 meter. So there will be 2 into 22, 4400, right, divided by 7 meter. So this is the distance covered in 40 seconds according to the question, right? Now let us just find out, therefore it's easy to find out distance covered in 1 second, let us find out, will therefore be equal to this same number 4400 divided by 7 meter, okay, divided by this number. That means this number will come down, this 740 will come down. The second, we should not bring a unit, not a unit but a number. 40 seconds, this much mean 1 second will be this one divided, right side divided by left side, like the mango method, right? So that way Z meaning 4 mangoes rupees 40, then 1 mango is how much? Common sense? Yes, that's right, 10. How do you get? Right side divided by left side, then you get the 10, like that. 40 seconds, this much distance, and 1 second will be right side divided by left side, just like the mango method, right? So next, therefore the actual time, now total time taken, let us find out this one. Total time taken, he went 1 round in 40 seconds, but that's not the total time he ran. The total time there, next sentence, what will be the distance covered and the displacement at the end of 2 minutes 20 seconds. So total time taken was 2 minutes 20 seconds. So we need to change to SI unit. We know now by now hour, minute and second. So you want to change minute to second, then 1 plus, so 60 seconds plus here 20 seconds. So 2 6 are 12, 120 therefore, plus 20 is 100. 120 plus 20 is 140 seconds. Is the total time that he ran, okay? The question is just saying it took 40 seconds to go 1 round. Doesn't mean he went only 1 round. He went for 140 seconds running, okay? So that is the time. Therefore, distance, look here, distance covered in 140 seconds, the actual distance covered in the actual total time. That's what the question is asking. So in 1 second, this much. So let us just cancel this one, 0, 0, and 4, 1s are 4, 1s are 4, 0. So 110 by 7. So we're getting here 110 by 7 meter is what you cover in 1 second. So in 140 seconds, just like we did here, 4 mangoes, rupees 40, then 1 mango, right side divided by left side, which is 10. So 10 mangoes will be this right side multiplied to this one, right? So there will be 100, like that. Here in 140 seconds means this one 110 divided by 7 meter multiplied to this number. But we shouldn't bring the unit, only the number, because we know left side unit should remain on left side, right side should be right side, okay? 7 2s are 14, 0, so this 2 into 11, 22, 00. So total distance covered by him is this one, 2200 meter. When the question is asking this, we have found out. Now we have to find the displacement. So let us just do one thing here. For displacement, you see here, in 40 seconds, okay, in 40 seconds, okay, he completes 1 round in 40 seconds. Question is saying, first statement there, an athlete completes 1 round of a circular track of diameter 200 meter in 40 seconds. So in other words, in 40 seconds, he completes how much? Common sense, he completes 1 round. Question is saying that, right? You can clearly see that. So let us use this one now. For displacement, we need this. Therefore, in 1 second, he completes how many round? Right side divided by left side. That many round. But we shouldn't bring that as a unit, only the number. Therefore, total time was how much? This one, right? So we write here, in actual time that he ran for 40 seconds, he complete 1 divided by 40 rounds multiplied to this number, isn't it? We know now this one now how to do this. 0 0 cancel, 2 2 2 7s are 14. So 7 divided by 2 rounds in the total time that he ran, that he completed 7 by 2 rounds, which in other words is by division. 2 3s are 6, so 1 remainder. So you can write the quotient, remainder, divisor. Remainder down, up, divisor down. So 3.5 rounds. 3.5 round of the ground. So that will give us the clue for displacement. So we write here, since in 3.5 rounds, let us look on the diagram. Suppose he started from here A, then let us go when 3 rounds, let us say 1, 2, and 3 here. And 3.5 round means half circle here, exactly. That means he will be ending here, final point here B, which is nothing but the ending point of the diameter, isn't it? That means, see here, 1 round, 2 round, and 3 round, and half means half circle. When half circle is semicircle, and the line that divides the circle into half circle is the diameter. So in 3.5 rounds, his initial, that means his initial and final positions, okay, will be the two ends of the diameter. So what it means is that after 3.5 rounds, 1, 2, and 3.5 rounds, starting point A, and he ended up at B means final point. So the shortest distance between initial and final point is called displacement. So that is, his displacement will be the diameter. I hope you're getting it. Diameter of the track, which is 2 multiplied to the radius of the track. So 2 into radius of the track is 100 meter. So the displacement is only 200 meter. The distance between, shortest distance between the initial and final point. Okay, so these are the two answers. The distance covered we have done, and now this one is the displacement. Okay, I hope you've got it.